Hello, this video will focus on basic data management in R. It would be very helpful for you to go back to the previous portions of the code and rerun those pieces of code just to make sure that you understand what's going on, but more importantly, so that you can open up the data that we are going to be working on. In particular, it'll be important to open up BMX and demo and to remember to merge those two objects into a third object called full data. So now that you've been able to open up your data set, you have a little bit of a sense of what your data look like. You may decide that you need to make some changes to your data. You may need to clean it up a little bit or add additional variables. So we'll talk about doing some basic data management strategies today. One of the first basic management strategies is often to recode a variable to some fashion that works better for you, the user. In this instance, on lines 168 to line 172, I have a variable that's called ridf1. And this variable was originally measured as 1, 2, 3, 4, and 5. It's a categorical measure. But it's hard for me to remember what these numbers relate to, so I want to add labels to them. And I've got those labels listed here. So the thing that's happening here is that I am taking my variable ridf. I am defining it as a factor or a variable that is categorical. It has levels of 1 through 5, and those levels correspond with the following labels. Once I've defined this variable in this way, I will pass this information to a new element inside of the object full data called race. This race variable will now contain the information that's been recoded as I've defined here. If you want to go ahead and run full data, run lines 168 through 171, you are welcome to do so. And I have that done here. Just so that we can convince ourselves that we actually did what we thought we were going to do, we're going to run two tables. One on the original variable ridf1, and you can see that it was coded as 1, 2, 3, 4, and 5 here on the bottom at the console. And then we're going to take a look at our new variable race. And as you can see, it has labels of those that are detailed over here that correspond with the numbers that we have. So that seems to have worked reasonably well. We're going to try this coding with a different variable. This time we're going to call it gender. And as you can see, we're still defining a factor variable, a categorical variable, which has two levels, and those levels refer to male and female. So we're going to go ahead and run that. And we'll also confirm whether it did what we thought it would do. Okay. Another great thing that you can do if you need to change up variables is to transform them. Sometimes we need to transform variables so they'll have distributions that are closer to a normal distribution. And so we can simply transform these variables from what they were. In this case, we're going to take the weight variable and we're going to just put a log base 10 transformation on that. And with that, we are moving that into a new element inside of full data called BMX WTT transform, little t transformed. So we'll go ahead and run those. And you can do all kinds of different transformations, not just log base 10. You can include other types of math. to make your transformations to your variable. So maybe you want to add a value to your variable. You can do that as well here, and it's not a problem. I'm going to go ahead and just keep this as normal. Now, sometimes you want to recode a variable. So for example, let's take a look at this variable DMD mart L. This is a marital status variable. I am going to first just run a table on DMD mart L. You can see that it has several categories, and it probably has some missings in here. So one thing that you can do is say, maybe I just want to do some sort of married versus not married variable. And so if the value of DMD Martel is equal to 1, I'm asking it to give it a value of 1. Otherwise, give it a value of 0. That's being done using this if-else function. If-else is really just a logical expression, and it says, if you see a thing, do another thing, otherwise do something else. And we're going to go ahead and run line 207. Nope, because I just highlighted the 0. So now we're going to run line 207. And we have this new variable called full data $married. Now, if you want to convince yourself that we actually did what we were supposed to do, let's run a table of full data $married, as you can see in 216. And if you compare with your previous table, the numbers match up. So if else is a really powerful statement for variable recoding. Another function that I like to use to recode is a function called recode. This function exists in the car package. So you will need to install yet another package called car. I've given you steps here. And I've also shown you that there's another way to invoke a package using a require statement. Again, library and require are functions that are equivalent in that they will open up packages, but how they do so is a little bit different. And it seems at this time that there's a preference for library over require. However, either one is fine, especially if you're starting out in R. I'm going to go ahead and require car. And now I'm going to line 229. So let's say, yeah, you know, there are more marital categories than just married and not married. And maybe I'd like to be a little bit more detailed about that, or put more categories in there. So you can use the recode function to do that kind of work. And so now I'm going to recode married one more time using this recode function. And I'm going to take the original variable DMD Martel in the object full data, and I am going to recode it in the following way. If it sees 1 in DMD Martel, it's now going to give a code of 1 for married. If it sees any value between 2 and 6, it's going to give a new value of 0. And if it sees any value between 77 and 100, it's going to give this value of NA, N-A, in quotes. So this is more of like a word NA rather than missing. So we're going to go ahead and run that. Now, I also want to take one moment to emphasize the use of NA. Recall that R defines missing as NA. However, it is possible to code something like I've done here, quote, NA, close quote. This would be considered a character variable. You could say it's nah. This is not equivalent to what R understands as missing. So be very careful, and if at all possible, avoid doing this. I only wanted to do it this way so I could bring it to your attention as something that could possibly go wrong in your data analysis and your data management. So it would be better actually to code it this way if you really want to code it as missing for R. For the purposes of making the point, I'm going to keep it as quote NA. All right. So if you run your table of married, you see now that you have the categories that you thought you would, and you have this third category of nah. It's not really helpful to analyze a category called nah. So if we were to do our due diligence, it would be better to recode this, make it NA, and now rerun it. And now let's take a look at that table one more time. Okay, your missings are now considered missing and are not being included in the calculation of the table. We will now recode another variable called FAMINC, or family income, and we've defined those levels of family income in the way that we have here. So you use the same recode function to take the original variable ind fmin2, and it recodes in the following way. When R sees a value anywhere between 1 and 5 in this ind fmin2, it is going to make a new value of 1 for the new variable. Anytime it sees a value of 13 in the old variable, it's going to give a value of 1 in the new variable. A value of 6 to 7 in ind fmin2 will then result in a value of 2 for the variable FAMINC, etc., etc. And in this case, you also see that I've now coded 12 as well as 77 to 100 as missing. Go ahead and run that and take a look at the table. All right, as we mentioned before, you can use math to recode variables. So what we have over here in line 257 is just one type of that kind of recoding. Here we wanted to make a new variable of BMI, which is weight over height squared. And we've done that here. Parentheses matter, so in this case, I wanted to ensure that R understood that I wanted it to multiply height together first as a whole, and then do the rest of the math. I certainly could have rewritten this code in this way, since it's what I've written here is full data height times full data height. You could have squared it like this, use a caret head and 2. But for the sake of maintaining transparency, I wanted to do it this way. And we're also just multiplying by a factor of 10,000. So you can go ahead and run line 257, but I didn't do that just now. I only ran the number to 10,000. So as you can see also, if you run just a little piece, you can do that even when you're within a line if it's highlighted. So now we run that line and we can take a look at that BMI variable using the summary function. And we see that the mean BMI is about 25.9. You also see that there's several decimal places for BMI, so maybe you want to just round that number, and you can do that using the round function here. And you're basically saying, okay, I'm going to take this element BMI2 that's inside of the object full data, and I'm going to round it to 1 decimal place. Once I've rounded, I'm going to send that information into a new element inside of full data called BMI3. And so you can run lines 263 and 264 and check your work. And even though it's listed here as 3, let us see something real quick. There. So now you can see that it's been rounded to 1. The other thing that you can see that I did not mean to do on this console, but here we are, is that you can see that you can wrap more than one function around a function to do what you need it to do. So the first step I did was run the mean, and then once the mean had been calculated, I also ran a round function to say take that mean and round it to 1 decimal place. All right, last thing we're going to do is create a new variable for obese versus not obese using that recode function, as well as a poverty variable. This time we're using the if-else statement. You can go ahead and run that on 274 and 275. All right. Now, you've made some new variables, you've tidied up your object full data a little bit with the variables that you want. And now maybe you don't want to run and work with the full object called full data. Maybe you only want to work with some of the variables. Up until this point, we have been focusing on talking about elements in an object using the element's name. But we can also think about talking about these elements using their numbers. So as I mentioned before, as you start thinking about streamlining your work, can you imagine that if you wanted to work with this variable BMD stats, you would have to refer to full data, $, BMD stats, and do your work. And that's fine, you can totally do that. But it would be faster if you could just say full data and refer to the second element inside of full data. So I'll give you an example. I'm going down to the console and we're going to do a mean of full data $, BMX weight. And I think this will do NA. Okay, so we have that. We could also say, I want to take the mean of full data and look at the second, BMX weight is the 1, 2, 3rd element in full data. So you could take The third element of full data, take the mean of that. And get the same answer. So by doing this, it allows you to more efficiently talk about and refer to the elements inside of any particular object. It allows you to make more generic some of your work. So now taking that concept to making a smaller data set with only the variables that you're interested in, you can revisit the name statement of full data and look at all of your names and pick which variables you want. In this case, I did 1, 2, 3, 4, 5, 6, 7, 8, blah, blah, blah. Let's just do this two ways. 1, 2, 3, 4, 5, 6, 7, 8, and all the rest of them. Full data small. Go ahead and run that. And then if you look at full data small, you have 10,253 observations and 13 variables. Okay. Another way to do it is colon. Run it again, and lo and behold, same number of variables. If you don't believe me, rename your full data small 1. You've got 13 variables, and you can go back to your original, and lo and behold, you have full data small 13 variables. They are equivalent. So you can make it even easier to write references to numbers by using the colon statement. The other thing that I want to do is make sure that I'm clear about what just happened in this line. In this line, what we did was we took the object full data and we identified several columns that we wanted to extract from full data. Those columns or elements inside of that object were numbered 1 through 8, 12, 13, 66, 67, and 68. All of that information then gets passed on to an object called full data small. So now let's say you want all the variables except maybe just a few. You can use, instead of C, you can use this value minus C to say, I don't want you to include these data. In this case, we're saying we're going to take out variable number 28 from full data, and then we're going to pass this new data set and put into an object called full data no 2. And so instead of having 75 variables like full data had, full data no 2 has 1 less, and now it has 74 variables. If you're selecting observations instead of columns, you take a slightly different approach. In this case, what you're going to do and what we want to do is we only want data from people with ages 28 or more. And so what we will do is we will go into this object, full data, and we say, pull me those observations for which the value of RID age year is greater than or equal to 28. I want all the rows that satisfy this requirement, and I want all their data across all of the columns. So you'll notice that that's why I have a comma and this space here. Remembering that when we think about reading objects, R thinks about them in a type of matrix format, the rows and the columns. And when you are referring to something that's related to an object, such as full data, you are going to allow it to sit inside of square brackets, and anything inside of that square bracket can be distinguished using rows before a comma and columns that are distinguished after the comma. So let us then build this up. Go ahead and run line 310, full data 8. Okay, right now full data 8 has 5,251 observations and 75 variables. That makes sense because if we look at the dimensions of full data, the dimensions of full data have 75 columns, and the dimensions of full data 8 also have 75 columns. It's just that they have a fewer number of rows. So only those people who are 28 years old or older. So now we got all the columns, but maybe we don't want all of the columns. So we'll go and ask for a smaller set of variables. We're building now on that previous full data 8. We will do that by, again, asking for us to do work in the object called full data, and we use a square bracket to denote that we are starting to look for something specific with the elements related to the rows and the columns. Here you have a comma, so that's going to distinguish everything for a row versus a column, and everything before the comma is referencing the rows. So all of the rows where the individual is 28 years old or older, and all of the columns. In this case, we want columns numbers 1, 2, and 3. You'll close your parenthesis, and then you go ahead and once you have everything there, you pass it to a new object called full data 8a. Go ahead and run it and see what happens. Let's take a look in the console at the dim of full data 8a. Aha, so we have 5,251 rows. Now, instead of 75 variables, we have 3. So your comma and the placement of the comma is very important. Remembering also, as a big reminder, anything that comes before the comma inside of a square bracket refers to the rows, and everything that comes after the comma refers to the columns. Square brackets help R understand that you're doing work specifically on an object. That was one way to do it, is working on the object itself, and we use this which function to do that work. But sometimes it can be hard to remember how to do that. So an alternative way to do it, because there's always more than one way to do something in R, is to use a really handy function called subset. Subset allows you to actually do everything that we just did, but in a tidy function. So the subset function that we're using here is saying, I want you to work in the object full data, and I want you to take all of the rows where full data ridge age year is equal to or greater than 28. And I want you to take the following variables. Here you can use variable names as well. You don't have to be stuck using numbers. I just wanted to keep them as numbers for comparison's sake. Go ahead and run full data 9, and let's look at the dim of full data 9. Oh ho ho, same number of variables and columns as we've had in full data 8. So again, same way to do the same thing, but in a way that may be more intuitive to some people by using a function called subset. This concludes our quick tour of data management in R. I want to also bring your attention to several important logical operators that are used in R, since we did use the greater than or equal sign here, I also want to bring your attention to several others. The and sign can be used as an and the piping sign can also be used, as or to refer to an or statement. Please pay attention here. Two equal signs is what R understands as equals to. If you use a single equal sign, it will get confused. So equal equals refers to equals to. When you're saying something is not equals to, it's an exclamation point and a equal sign. And we have less than or greater than signs. And so you can do something like I've identified here to say x is between 0 and 1. Another one that I didn't mention before is two functions. These are actually functions. One is called is.na, and another one is called is not na. So sometimes, especially if you're doing if-else statements, you might say, if this value is equal to missing, do the following. Or if this value is not equal to missing, do the following. This function is super powerful and very helpful. Thank you so much for your attention. As always, please feel free to ask questions at the email address above, and we'll see you at the next one. Thank you.